In this video, we're going to go through using the conversion factors that are generated from a mole. The last session on the video, what we did was we looked at how you generate conversion factors from the mole. And there's 4 conversion factors that are generated from the mole if the substance is a gas. If it's not a gas, we learned that you can't put that last conversion factor down. In this video, we're going to be looking at using the conversion factors from the mole. So now, how do we use these conversion factors? What is the question going to look like? So, for instance, what if they asked us the question, how many moles are there in, let me think for 1 second. How many moles are there in 28.0 grams of N2? How many moles are there in 28.0 grams of N2? So what we're going to do first in each of these problems is we're always going to write down the given information. So the given information in this case is 28.0 grams of N2. But we don't want our answer in grams of N2. We want our answer in moles of N2. So what we're going to do is we're going to write down the 4 conversion factors that we have for N2. So my conversion factors that I have for N2 are the following. We know that 1 mole of N2 is equal to, if we go to the periodic table, each N is worth 14.0. We're going to go to the nearest tenth. So we know that 1 mole is 28.0 grams of N2. We also know, and actually I put this out of order. I should have put this one first, but it doesn't matter. They're all equal, so I'm just switching these two. 1 mole is also equal to 6.02 e to the 23rd, and these are going to be called molecules of N2. And because N2 is a gas, we're going to put 22.4 liters of N2. So these are my 4 conversion factors. And here's the process we are always going to use. So this is important. The first thing is we write down what's given, 28 grams of N2. Then I multiply by my conversion factor. I'm going to multiply by my conversion factor. My conversion factor will always involve 2 of the 4 pieces that's available to use. Always. You're going to make a conversion factor, which is just a fraction, and there's going to be 1 of these that goes to the bottom of the fraction, and 1 of these that goes to the top of the fraction. We will always put the bottom in first because whatever units you have right here, you're going to match the units up down here. So if we had molecules of N2, I would choose this to go to the bottom because it would match. So in this case, because it says grams of N2, I'm going to put whatever piece this is into the bottom. So I'm going to put 28.0 grams of N2. Now, it's a coincidence that the 28 and the 28 match in this case. You always match the units that are here to go on the bottom. And whatever the question is asking for, because it says moles, we're going to put that piece on the top. The reason we match up is because you have units on the top and units on the bottom. So the grams will cross out because they're the same. The N2 will cross out because it's the same. Now we take the 28, we multiply it by 1, and then we divide it by 28. Well, that comes out to exactly 1. So 1 mole of N2. Now, some of you are saying, well, I knew that when you started because you said how many moles are there in 28 grams, and 28 grams is equal to a mole, so it should have come out with 1 mole. And you are correct, but a lot of times it won't work out that easily where it comes out, and so it's harder or more difficult to do it in our head. So for instance, let's ask this question. How many grams are there in 3 moles of boron? Boron is an element on the periodic table, and it's right here. Its molar mass is 10.8. So how many grams are there in 3 moles of boron? The very first thing we're going to do is always write down what they gave us. So I'm going to write down 3 moles of boron, and then I'm going to multiply by an empty fraction. My rule is that one of my 4 conversion factors goes on the bottom and 1 goes on the top. So let's write out the conversion factors. The conversion factors for boron is 1 mole of boron is equal to 6.02. I'm going to put it in the order that I previously put it in. 6.02 e to the 23rd atoms of boron, which is equal to, I go to the periodic table and it's just 10.8. The reason I had to double it up here was because it's not just N, it's N2. So 10.8 grams of boron. And we have to be careful. I don't get to continue. Boron is not a gas. So the last piece, I don't get to put an equals here. It doesn't exist. It doesn't equal 22.4 liters. So now, as I've mentioned, we write down what's given. We make an empty fraction, and I have 2 choices. This time I have 3 things to choose from for these 2 openings. How do I choose? The first is whatever units I have right here, I match up at the bottom. So because I have moles of boron, I'm going to put moles of boron down on the bottom. 1 mole of boron. So now for the top, I have 2 choices. I can choose this to go to the top, or I can choose this to go to the top. How do I know? Because the question says how many grams. So I'm going to pick the one that says grams. So 10.8 grams of boron. So I need to take my calculator and I need to multiply 10.8 multiplied by 3, and that gives me 32.4. Notice the moles of boron cross out with the moles of boron because one's on the top, one's on the bottom. The boron crosses out, and I get 3 multiplied by 10.8, and then I divide by 1, and that gives me 32.4, and the units are grams of boron. That gives me my answer. My final question will be, how many atoms are there in, and let me think of a good question, 80.2 and 80.2 grams of calcium. How many atoms, if I had 80.2 grams of calcium, how many atoms are there? Well, the first thing I'm always going to do on these types of problems is I'm going to write down 80.2 grams of calcium, and I'll abbreviate calcium, and I'm going to multiply by a conversion factor. A conversion factor is just an empty fraction, and I'm going to put the equivalent statements from the conversion factors into the empty fraction. Conversion factors. Well, I know that 1 mole of calcium is equal to 6.02 e to the 23rd because it's just calcium. I'm going to put atoms of calcium, which is also equal to, if I go to the periodic table, it comes out to 40.1 equals 40.1 grams of calcium. And I do not get to put the last conversion factor in because calcium is not a gas. So I don't get to put that in. So here's my 3 conversion factors, not my 4th. And I have 2 choices here. So I get to put one of these in the bottom and one of them at the top. How do I know? I want to match up whatever units here to the bottom. That is a very important point. So I put 40.1 grams of calcium. And then on the top, how do I know? Because it's asking for atoms, I want to put the atoms. 6.02 e to the 23rd atoms of calcium. Now, the grams should cross out with the grams, and the calcium should cross out with the calcium. So my answer is only going to be in atoms of calcium, because those are the units that are left, atoms of calcium. So now I look here and I see 80.2 on the top and 40.1 on the bottom. That's a ratio of 2 to 1. So I can reduce that. And now it's 2 multiplied by 6.02. That gives me 12.04 e to the 23rd. 12.04 e to the 23rd. Now, in scientific notation, as we spoke, the rule is you're only supposed to have one non-zero digit to the left of the decimal. So technically, I would need to move the decimal over, and this would be the same as 1.204 e to the 24th because I had to move the decimal place one place over. This is our first introduction into using the conversion factors that we previously generated in terms of how to move from grams to moles, or moles to grams, or grams to the number of atoms, using the conversion factors from the mole.